relative extrema. So I have the graph here, and I want to talk a little bit about relative extrema, and then we'll look at a little bit more formal definition. So it's called relative, first of all, is because it doesn't have to be the biggest point on the graph or the smallest point of the graph when we talk about relative max and mins, but in a certain region it has to be the highest point or the lowest point. So here and here I have relative max. So relative maximum, or sometimes it's relative maxima is how they'll refer to it, is just in some interval, that's the highest point for this graph. It's not the highest point on the graph, because we can see by this arrow, this graph continues just to shoot up there, shoots down the other direction, but in the interval, it's going to be the highest point. I have some relative minimums here and here. Again, in a small interval, it's going to be the smallest point around. So we're going to use our first derivative to be able to figure out where these values are. And there are a lot of applications for it, because if I want to say, well, when am I peaking for my profit? And then, so I peaked at this interval, and I could do this over a time. I want to know what that maximum was, what I was peaking, and then I can also look to see what was going on around that time, or how I was maybe advertising, whatever it is. Then I can start kind of investigating so I can get back to whatever the peaks might be. And the same thing is true with when there's a minimum. I want to know what happened, that I had this big dip, and what was going on around, so that I can make some adjustments. So we have a relative max. And my relative maximum is when I have some open interval and f of x is less than, f of c in this interval. So we have a function, and it's going to be an open interval AB containing c, which is just some point. So for every other value of x in that interval, if they're all less than or equal to f of c, then that's going to be my maximum. So that's what this is, right? Up here, this point, every other point around there are going to be less than or equal to this y value of 2, so that's why it's a maximum. The relative minimum is when I have f of x is going to be greater than or equal to f of c. So c again is my point, and if everything else near it on this interval AB is bigger, then f of c has to be a minimum. So what we're going to do is use the first derivative test. And that's going to help us find extrema on an interval. So first, we're going to find the critical numbers. After we find those critical numbers, and remember that's when f prime of x is equal to 0, or when it's undefined. That's how we find the critical numbers. And then we're going to put them on a number line. And what we're going to do is look at what's happening on either side of our critical number. So if it goes from positive to negative, that means my function was increasing and then decreasing, then I have a relative max. If it goes from negative to positive, so that means it was decreasing and then increasing, then I have a relative min. And if it doesn't change signs, then there's no extrema there. So there's one little caveat to this, and that is the fact that I have to make sure that the function actually exists there, right? So some of the earlier examples that we looked at when we were looking at just increasing and decreasing, it could be increasing on one side and decreasing on the other side of a value that actually doesn't exist. So you have to be a little bit mindful. Always keep the domain in mind when you're going through these. So the problem that I had put at the beginning of this section, we looked at f of x is equal to x squared. So f prime of x was 2x. And when you set that equal to 0, you get x is equal to 0. So I'm going to just put 0 on the number line. And I'm going to pick some value. It doesn't really matter which, but some value to the left and some to the right. I just don't want to pick numbers that's going to take me forever to evaluate. So this is my derivative, 2x. When I plug in negative 1 into that, I get a negative value. And when I plug in positive 1 into that, I get a positive value. So if it's negative, that means my function was decreasing. Positive, that means it's increasing. So therefore, because it was decreasing and then increasing, I have a relative minimum. And we know that x squared, that function just looks like that. So decreasing, increasing, I have a horizontal tangent right there at 0. All right, again, I want to find relative extrema. I have 2x cubed plus 3x squared minus 36x. So first thing I do is find the derivative, and that gives me, 6x squared plus 6x minus 36. And then I'm going to factor out that 6 just to make things a little bit easier. And then also I have to set it equal to 0. So I get 6 times x plus 3, x minus 2 equals 0. So I get two critical numbers. X equals negative 3 and x is equal to 2. Alright, now that I have my critical numbers, I'm going to put them on the number line. So negative 3 and 2. And then again, I'm just going to pick numbers in the interval. So I'm going to pick negative 4, and then for the middle, 0, and then 3. I'm going to plug it back into this just because it's easier. So we don't have to worry about the 6. It's just a 6. It's positive 6. It's not going to change the sign of anything. So I'm going to really just focus on this part. So when I plug in negative 4, I get negative 1 here and a negative 6 here. So a negative times a negative gives me a positive. I don't really care what the exact number is. I just care whether it's positive or negative. When I plug in 0, I get 3 times negative 2, which is negative. And when I plug in 3, I get 9 times 1, which is positive. So it was increasing and then decreasing and then increasing again. So here I have a relative max, and here I have a relative minimum. Now the only other thing that I have to think about is sometimes they ask you what is the actual relative max and relative min. Then I have to plug it back into the original equation because that's an ordered pair. So our original equation was 2x cubed plus 3x squared minus 36x. So I'd have to plug in negative 3 and I did this out before, so that gave me 81. So at negative 3, 81, I have a relative max. And then when you plug in 2, we get negative 44. So here's my max. And then at 2 comma negative 44, oops. Let me try that again. 2 comma negative 44, I have my relative minimum.